Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 6, Section 4, titled Point-Slope Form and Writing Linear Equations. By the end of this video, you will have reviewed methods for using point-slope form of a line for graphing. This includes using point-slope form of the line, writing equations in point-slope form, and then using 2 points to write an equation. At the end of the review, you will be writing linear equations using data from a table, and then you'll look at a real-world problem. If you'd like me to cover any of these topics in greater detail, please leave a request in the comment section below. Please subscribe to this channel. If you find the video to be helpful at all, I would really appreciate it. Thank you. Okay, objective 1, using the point-slope form. So let's start with a definition. What is the point-slope form of a linear equation? So the point-slope form of a linear equation is a non-vertical line. Remember, we've talked about that in the past, that a vertical line, we can't include those, right? Because they're undefined, right? Because there's no slope. It's infinite, so to speak. Anyways, the line that passes through the point x1, y1. So the variables with the subscript, those are the ones that we know, right? So think of it that way. If the variable has a number with it, a subscript, then somewhere in our problem, the value already exists. It's the y, the term here, the y and the x that are the unknowns, right? And so they were given a line that passes through the point of x1, y1 with a slope of m. Okay, and here's the equation. Y, the y value we're looking for, minus y1 is equal to m, the slope, times x minus x sub 1. Okay, so let's try one here. Suppose you know that a line passes through the point 3 comma 4. Let me get a color that'll look good on here or better on here. 3 comma 4. That's the 3 is the x, the 4 is the y value, and a slope of 2. So you can quickly write an equation of the line using the x and y coordinates of the point and the slope. It's pretty straightforward. So here it is. Y minus y sub 1. And y sub 1 is this y value right here. It's the 4. That's the one we know. So it's y minus 4, okay, is equal to 2, which is that they tell us is the slope right here. 2 is the slope, times x minus 3. And we see here that the minus 3 we know that we're given the x value. And it's not minus 3 that we know, it's the 3 we know, but we subtract it from this x term. So it's x minus 3 and or y minus 4. Okay, so and keeping in mind that if this was a negative, let's say for instance this was a negative 4 right there, then it would be y minus a minus 4 is equal to 2x minus, what was it, 3. Okay, so you see how that would have changed? Okay, but that's not what the case in this problem is, but I'm just showing you this for example, okay? So now that you have this equation, there is your equation. So you can use the definition of slope to verify that y minus 4 is equal to 2 times the quantity x minus 3. And this is the equation of the line through the points 3 comma 4 with a slope of 2. So how do we do that? We take y2 minus y sub 1 divided by x sub 2 minus x sub 1, and that is your slope. So where do we get these values from? Well, we're going to get y minus 4. We know that here's y minus 4 right up here. Y minus 4 divided by x minus 3 is right here. And then you're going to multiply both sides. Here's how, and set that equal to 2. And then we're going to multiply both sides by x minus 4 to clear this denominator right here. We want to get rid of that denominator. So what we're going to do is we're going to multiply it over here on this side. So it's here, it's multiplying here on the left-hand side and on the right-hand side. Well, then these two will cancel each other out. And so now you're going to have y minus 4 times the quantity 2, which is the slope, times x minus 3. And there it is, the equation y minus 4 equals x times the quantity x minus 3 is the point slope form of the linear equation. Okay, example 1, graphing using the point slope form. So now they're going to give us an equation right here. Graph the equation y minus 5 is equal to 1/2 x minus 2. Here's the equation. Now, with that information is all you need to graph that line on that graph there. So what do we do? The first thing they're going to tell us is, we're going to go right here. I'm going to change my line color. They're going to say the equation shows that the line passes through point 2 comma 5 and that it has 2 comma 5 and it has a slope of 1/2. Why is it 2 comma 5? You look here, it tells, here's your x value, x minus 2. So it's the 2. And over here, it's the y minus the 5. Here's the 5 right here. And the slope is right here. There's your slope, 1/2. Okay? So now that you have that, you're going to plot that. You're going to look at the equation and you say, oh, x comma 5, 2 comma 5. So I'm going to go over here. I'm going to go x2, 1, 2, 3, 4, 5 up. And here, right there, is your 2 comma 5 point. Now you've plotted the starting point that they wanted you to graph the line passing through that point right here. So we got, now you just have to figure out how to draw the line. Well, how do you draw the line? You take the slope, and this slope is 1/2. So that means 1 is y, 2 is the x, right? It's y over x. It's rise over run. Y over x. Okay? 1 over 2. So the rise is 1. So we're going to go up 1, right here, and over 2. 1, 2. And then you're drawing right there. So I'm going to do red here. So you start here at this point here, okay? And you end at this point right here. And this was up. It went up 1, and over 2 from the point that was on the line. And then you're going to draw your line through there. So the line gets drawn right through here. And there's your line. And oh, by the way, where's the y-intercept? The y-intercept, here's 0, right here, 4. The y-intercept in this one. So if we wrote this in the slope-intercept form, you'd see that this ended up being 4 right there. Okay? So that's it for this one. Okay, example 1, check your understanding. So let's graph the equation. Y minus 5 equals negative 2/3 times the quantity x plus 2. So this is check your understanding. So I'm going to let you pause the video and try this. And then when you come back after the pause, we'll work it together, okay? So what do they want you? They want you to figure out how to graph this equation, okay? Okay, go ahead and, oh, before you go, be careful with the X and Y terms. Make sure you look at the signs and try to figure out what that means on those terms. Okay, I'll wait for you. Okay, I'm assuming that you've stopped and you've paused and you've tried this, and now we're back together. So let's do it. So let's look. What do we have here? We have a negative 5, and so you know it's y minus 5. And that's our y value. So I'm going to go here. I'm going to go this. I'm going to do this. I'm going to say 5. I'll put a comma right there. Okay. So now I got to figure out the x value. So what is the x value? It says plus 2. Well, in order for this to be plus 2, what did it mean? It meant that it was x minus 2, right? Because it's the equation says minus, right? X minus. What was it? It was y minus y sub 1 is equal to m times x minus x sub 1. Okay? So don't forget that minus there. And if this is positive there, that means that it had to be like I've drawn it here, which means it's negative 2. So the x value is negative 2. So now we have our point on the graph. So we're 2, 5, halves, 2, 3. So let's draw the graph And let's do 1, 2, 3, 4, 5. If I need more, we'll do more. 1, 2, 3, 4. I'm trying to keep these as similar in terms of spacing. That way the graph will be more accurate appearing anyway. It's not going to be perfect. So what is our point? It's minus 2. Here's x, and here's y in the negative, x in the negative. So this is negative 2 right here, negative 2 at that point, and y is 5, right? So when x is negative 2, y is 5. And that 1, 2, 3, 4, 5, and 2, it's right about there. So now we have a negative 2/3. And I think we spoke of this before. This is negative, so that means what? That means that the slope is going down, right? The negative slope means it's going from left to right, it's going down. So what are we going to do? The 2 is the y part, and the 3 is the x part. So the negative here we're going to keep with y, because that's where you're doing the up and down. Okay, we seem to always go from left to right on the x, but you can go up or down on y. So we're going to go down 2 on y. From right here, we're going to go down 2, 1, 2. I'm just going to put a dot there. And then we're going to go to the right, 3. We're going to go 1, 2, 3. So that means that we started with a point right here, and I will let me mark that with I'll do a blue. So this point here was what? This point was negative 2, 5. That's that point right there. And this point right here is what now? It's positive 1, 1, 2, 3. So it's 1, comma 3. 1, comma 3. That's our second point. And the line drawn, if I can draw it, you know I don't draw very good. I want to put that line right through here. Okay? That's the line that you draw for this. Okay? Good. Okay, example 2, it says writing an equation in point slope form. So write the equation of a line with slope negative 3 that passes through the point negative 1, 7. And we were just basically, you know this already. We've just done this, right? So we're going to do it again. A little more practice. So what do? We start off by writing the standard equation for the standard form. And that was right here. Y minus y1 is equal to the slope m times the quantity x minus x sub 1. And now we substitute our terms. So we look over here, we see, oh, here's our y term way over here on the right. So it's positive here. So that's going to be negative here. So it's y minus 7 times, or not times, equals negative 3. Here's our slope, negative 3, right here, negative 3, times the quantity x minus a minus 1. So here we put in this one had a negative number, negative 1. So since it was negative, we kept the negative and then put in the parentheses and had to write the negative 1 right there. I'm going to delete that so it's clear. I don't want that to be unclear when you are looking at it maybe a little later. So that's it. So you see here that this is the negative 1 ends up being negative the negative 1. Okay, and then you rewrite it so that you get rid of this double negative here. So here we're just getting y minus 7 is equal to negative 3 times x plus 1. Okay. Okay, example 2, checking your understanding. So why don't you go ahead and take time and pause this video and try this on your own. When you come back, I'll be here. We'll do it together. Okay. It says write the equation of a line with slope 2/5 that passes through the point 10 minus 8. Okay. I'll wait for you. Okay, so let's work this together. So first thing we're gonna do is let's write the standard form of the point slope equation, right? And what is that? That's y minus y1 is equal to m, the slope, right, times x minus x1. That's the equation. So now let's substitute. What are we going to substitute? We're going to substitute for y1. we're going to substitute the y value, and the y value is minus 8, okay? That's our point, minus 8. So here we're going to say y minus 8 is equal to, and the slope is 2/5, is equal to 2 divided by 5 times x minus 10, okay? And that's basically all we have to do now is straighten up this over here with the y on the left because of the two negatives. So I'll say y plus 8 is equal to 2/5 times x minus 10. Okay, there's the solution. Okay, example 3, using 2 points to write an equation. So in the past we had like point slope, right, or slope intercept. So now we had the slope. Now we don't have the slope. We just have the 2 points. So we have to create the slope from the points, which is pretty simple. Okay, so if it says here, if you know 2 points on a line, first use them to find the slope, and then you can write an equation using either point. So our problem here says write equations for the line in point slope form and then in slope intercept form. Our 2 points are what? They selected them for us. We have a point right here. This is 2, 3. And the other one is -1, -5. That's our other point. And I'm going to tell you here that when you're doing the slope, it doesn't matter which point you choose as your point 2 or your point 1. As long as you're consistent, you can use either one. It'll come out with the same answer. In this case here, the problem says y2 minus y1, x2 minus y1. They're calling this one down here, this point here, the y2 point, or the point 2. And here's point 1 up here on the top. So it doesn't matter which, as long as you're consistent. So that we're saying point 2, y2 is -5. See it right here? And then up here is point y1, because now we're calling this point up in the top point 1. So, and it's 3. And so it's -5 minus 3 gives you a -8. And then doing the same thing for point 2 down here, they call this point 2, so it's y and -1. So here it is, -1 is your x term now, minus whatever your other term up here on the top is, which is 2, minus 2. So now -1 minus 2 is 3, -3. So -8 over -3 is a positive 8/3. There's our slope, 8/3. So now using either point, and it doesn't matter which one you choose, you can write in point slope form. So they chose up here to use the 2, 3. Now you're not dealing with the negative signs, I guess. Have to do one extra step. So when we do that, we start with our formula. Y minus y1 equals m times the quantity x minus x1. Okay, and we picked the 2, 3 point. So it's y minus 3, the comma 3, right? Y minus 3 equals 8/3 times x minus the x term, 2. And there's our equation. And from here now, we can write in, this is our point slope. We can now write slope intercept. We can take, and they say using this equation here, they want us to use that equation to get the slope intercept. We already know the slope. We just need the y-intercept. Well, how do we get that? We start with our equation, and what we're going to do is we're going to subtract 3, or add 3, I should say, to both sides to get the y by itself, because it's y equals something, right? So what do? We add 3 to both sides. So y is equal to 8/3 x. We multiply out the 8/3 times x right here. 8/3 times x. And then we do the 8/3 times -2. And you'll get 8/3 times 8 times -2 is -16/3. Right? We have to convert the 2 to thirds so that we can, when we multiply them here, we're going to get thirds, 2 over 1, so 16 over 3. Okay, and then we already have in here 5. I could say this: 5 times 3 is 15, 16, right? Now there's the 16 thirds. And now we're going to subtract the 3 from it, then that's 9 thirds. The 3, negative 3 is equal to, in our case, is equal to negative 9 thirds, right? So now over here, we have adding 9 thirds to our negative 16 thirds. And when you do that, you're going to get 7 thirds. 16 minus 9 is 7. So you're going to get 7 thirds. I'll write that in something you can see here. We're going to have 7 thirds. And what they're doing is they're rewriting it then is 2 1/3, which is 7 thirds. And then we can't forget that it was negative 16 plus 9 thirds, which gives us still a negative, or a negative 7 thirds, negative 2 1/3. So our answer now in slope-intercept form, it's y is equal to 8 thirds x minus 2 1/3. Okay, and if you look at the y-intercept on our graph, you can look at here's 0, and then we go down to negative 1, going down the y-axis, and then we get to 2, and then you see that the intercept is a little below the 2, right? Right there. It's 2 1/3. It's a third of the way through the square. Okay, good. Okay, example 3, check your understanding. So it's your turn. Go ahead, pause the video and give these 3 a try, okay? See what you come up with. And I'll just start off by telling you that it's the same problem from the previous slide. So things you learned from the previous slide, I feel you can go ahead and use it, the slope or whatever you can remember. Or you can back up and look at it again. Anyways, I'll wait for you. Okay, so we're going to assume that you've done that. So, and I said earlier that you could go back and check the previous slide. So what did you learn? You learned one thing is that you learned that the slope is equal to 8 thirds, right? So you don't have to calculate that again. So let's go ahead and do it. They want us to now pick, they want us to use the point slope form. Last time they said use the 2, 3, right? Now they want us to use the 1 comma, negative 1 comma, negative 5. Let's try it. So I'm going to write down here, I have the slope. I'm going to say y minus y1 is equal to, we can even put it in right now. I'll say m. M times x minus x sub 1, right? That's the equation we're going to deal with. So we're going to fill it in. Y minus y1. Well, y1, they want us to use the negative 1, negative 5. So I'm going to have to put a parenthesis here. Negative 5 is equal to m. Well, we're going to substitute 3/8 or 8 thirds. 8 thirds times x minus, okay? And it's a minus 1 for the x term. So I'm going to do a parenthesis minus 1, okay? And I'm going to close that off. So now we're going to straighten this out so we get rid of those double negatives. So we're going to have y plus 5 equals 8 thirds times x plus 1. Now that is our equation right there for the point slope form. So now they want us to find the equation using in slope intercept form, right? So what are we going to do? We're going to take this equation and just rewrite it into slope intercept. I'll do it right here. So I'm going to say y plus 5 is equal to 8 thirds times x plus 1. So what do? We do 2 things. We're going to subtract 5 from both sides because we want to get the y by itself. So we'll have y is equal to 8 thirds. We're going to take care of the distributive property. 8 thirds times x is 8 thirds x plus 1. Okay, I'm just going to, which is, excuse me, 1 times 8 thirds. Excuse me. I'm trying to think in my head and at the same time solve the problem. It's plus, so now it's just 8 thirds. 8 thirds, okay. So those two, and we have the negative 5 over here, minus 5. So next step, I'm going to say y is equal to 8/3 x. I have 8/3 plus 8/3, and I have minus 5 is how many thirds? 5 is 15/3. 15 thirds. Okay, so now we have that. So now we're going to combine 15/3 and 8/3. So it's minus 15/3 plus 8 is what? 8. What it for 15 is 7, correct? Okay, so y is equal to 8/3 x minus 7/3. And what is that? What is that? So now that equation is y equals 8/3 x minus 2 1/3. So now we're going to go to problem 3. So it says, what is true about the equation you just wrote in part B right here, this equation, and that in step 3 of example 3, the previous slide? Well, what's true is it's the same equation. They're the same. They're the same. So what they're showing you here is that it doesn't matter which point you chose. If in the previous slide we chose the 2 comma 3, in this slide you chose -1 comma -5, but you get the same slope-intercept form of the equation. So it shows you it's the same equation, right? Okay, good. Objective 2, the first slide in these objective slides here. So writing linear equations using data. You can write a linear equation to model data in tables. Two sets of data have linear relationships if the rate of change between the consecutive pairs of the data is the same. For the data that have a linear relationship, the rate of change is the slope. We kind of know that. Rate of change is slope. We've kind of gone over that, okay? You can write a linear equation to model data in tables. Two sets of data have a linear relationship if the rate of change between the consecutive pairs of the data is the same. And you'll see that. We're going to have some examples of that. And again, it says, for data that have linear relationships, the rate of change is the slope. Okay. Okay, example 4, writing an equation using a table. Is the relationship shown by the data linear? That's the question. You see the data in the chart. If so, model the data with an equation. Step 1, find the rate of change for consecutive ordered pairs. Well, the ordered pairs are these right here. Let me change my color a little. So the ordered pairs are the -1 comma 4, 3 comma 6, 5 comma 7, and 11 comma 10. Okay, those are the consecutive ordered pairs here. Okay, so what they want to know then is you look between two sets of data, the x and y data, so the x comma y, right? Two sets of it, and determine if the slope, if the change is constant. So looking at the y value, we go from, in our case here, we go from 4 to 6. That's a step of +2, correct? From 4 to 6 is 2. 6 minus 4 is 2. And on the x side, you go from -1 to 3. Well, that's a change in 4, right? From -1 to 3 is a change of 4. 3 minus a -1 is 4. So if you do the math on this particular set, this set here, excuse me, between these two, you see it's y of 2, x of 4. y2, x 4. And in that case, you get 1/2. Let's do the next one. 7 minus 6 is 1. And on the x side, it's 5 minus 3 is 2. So again, it's 1 divided by 2, or 1/2. And how about 10 minus 7 is 3. And 11 minus 5 is 6. Well, what are 3/6? That's 1/2. So this is linear data with the slope of 1/2. So they say write the equation. So what are we going to do? We're going to say y minus y1. I'm going to change colors. y minus y1 is equal to m times x minus x1. You know that equation. So substitute, pick whichever one you want. The easiest one is probably the 5 and 7. Maybe not. Maybe the 3 and 6. It really doesn't matter which one you pick. But you can substitute the 5 and the 7 and the for the x1 on here, right? So what does that come out to be? It comes out to be y, right, minus the y value is 7, okay, is equal to m. The m is the slope, 1/2 times x minus 5. That's it. That's what they want. They want us to use the point and the slope to come up with that from the table. There's the equation of the data in the table. Okay, example 4, check your understanding. So again, you know that this is your turn, but pause the video and give it a try. And when you come back, we'll work it together. Okay, let's give this a try. So is the relationship shown by the data at the right linear? We're going to do the same thing we did in the previous slide. If so, model the data with an equation. Okay, so let's take a look at it. Let's go from, okay, I have yellow selected. So if we go from -3 to the -7, so that's -3 minus a -7, so that's +7. So the difference here is 4. Okay, and we go -1 minus a -11, which is +11, gives us 10, right? Okay, so now let's pick one more to make sure the data is linear. -1 minus 3 is how much? So it's minus a -3, so it's -1 plus 4 plus 3 is, right? Plus 3 is 2. And what's it on this side? 4 minus a -1 is 5. I'm going to go from here to here. This is 5. And it really doesn't matter, but you could do the last one. 5 minus a -1 is 6. And 19 minus 4 is 15. Okay? 6/15 is what? 2/5. 2/5. 4/10. 4/10 is equal to 2/5. So this is linear. So now let's write the equation. Y minus y1 is equal to m times x minus x1. There's the equation. General form, let's fill it in. So we've got y minus what? Our y term. Well, let's pick one. It don't matter. Let's pick the y. Let's pick this 5. It's easier. Minus 5 is equal to 2/5. There's our slope. 2/5 times x minus 19. Case closed. There's our answer. Okay? So it is linear, and there's the equation of that line that's formed from the data in that table. Okay, example 5, it's a real-world problem we're going to solve here. Is the relationship shown by the data linear? If so, model the data with an equation. That's exactly what we've been doing for the last couple slides. So what's the first step here? We're going to say find the rates of change for the consecutive ordered pairs. And we're going to do it for all three of them. The mathematics is here. The first one is 6.3 divided by -3.5. Here's the 6.3 from right here, the 6.3, and the -3.5. Y divided by x. Then you go to the next one. 2.7 divided by -1.5. Here's our 2.7 divided by -1.5. Then finally we get the 207 minus 206.6 is 0.9. And we get 2.5 minus 3 is -0.5. Okay. So now, if we divide these, as we've done along here, we find out that each one, 6.3 divided by -3.5 is -1.8. I guess I could change the color. Is -1.8. 2.7 divided by -1.5 is -1.8. And 0.9 divided by -0.5 is 1.8. So the relationship is linear. the rate of change is negative 1.8 degrees Fahrenheit per 1,000 feet of altitude. So the higher you go, the boiling point of water goes lower. Okay, it'll boil. So if you're up high enough, you can boil water at 200 degrees or 180 degrees or whatever. Depends on the air pressure is what it really amounts to. So use the slope and the point to write an equation. It's the slope at any of those points. We can pick any one we want. So the slope we know is negative 1.8. So here's my equation coming. Y minus y sub 1 equals m, the slope, times x minus x sub 1. Filling in and substituting, y minus 206.6. So we're picking the third one down here, 206.6. I'll change color. There we go, 206.6. And that equals negative 1.8. That's our slope, 1.8. And x minus 3. And here's the negative 3 right over here, the negative 3. So that's by doing the substitution. So the equation y minus 206.6 is equal to negative 1.8 times x minus 3 relates the altitude in thousands of feet, x. So here it is, altitude in thousands of feet to the boiling point temperature in degrees Fahrenheit. So there you have it. Okay, example 5, check your understanding. Is the relationship shown by the data in the table linear? If it is, model the data with an equation. So I'd like you to pause the video and give it a try. And when you come back, we'll work it together. Okay, I'm assuming you've done that. So let's figure it out. So what is the slope of this line? Is the data linear? So let's find out. So here's on our y side, the output, okay? We have 3130 minus 3030. I'm going to change this to a dark blue. And that is equal to 100. 3230 minus 3130 is 100. And 3330 minus 3230 is 100. So the changes in y is 100 in each case. Changes in x, 62 minus 68 is negative 6. 56 minus 62 is negative 6. And 50 minus 56 is negative 6. So there we have it. So this is going to be, the slope is 100 over negative 6. So m is equal to negative 100 over 6. But this can be reduced, right? So let's change it to 100. It's m is equal to negative 50 over 3. We divide the top and the bottom by 2. Now we have our slope. Let's just pick an equation. Y minus 1 equals m times x minus x1, right? Do our substituting. Y minus, the y value is 100, equals m, which is negative 50 thirds, negative 50 thirds times x minus, right? And in our case, it's 68. 68. There's our equation. Y minus 100 equals negative 50 thirds times x minus 68. Okay, objective 2B, writing linear equations and using data. So here's a little follow-up. We're going to review what we talked about. So first, in example 5, you could rewrite y minus 206.6 equals negative 1.8 times x minus 3 as, you could rewrite this in slope-intercept form, right? And if you do that, you're going to get y equals negative 1.8 s, okay? That was, okay, plus 212. This form gives you useful information about the y-intercept. For instance, 212 degrees Fahrenheit is the boiling point of water at sea level. Okay, so that's one thing we can think about here. And then the last thing we want to look at here are the 3 forms of linear equations that we've studied so far. First, the slope-intercept form, with y is equal to mx right here, let's see, y, I'm going to change my colors to a dark blue here. I like this dark blue. Y is equal to mx plus b. That's slope-intercept. M is the slope, and b is the y-intercept. Here's an example. Y equals negative 2/3 x plus 5/3. 5/3 is where the y-intercept is, and the slope is negative 2/3. It's going down. It's negative, so it's going from left to right. It's going down this direction, okay? Next standard form, ax plus by is c, equal to c. The a and b are both non-zero, and in this case, we have 2x plus 3y is 5. There's a form. And this is good for finding the x and y intercepts. Remember, you set x to 0 and you get the y-intercept. You set y to 0 and you get the x-intercept by solving the equation. And then there's the point-slope form. Point-slope. Y minus y1 is equal to the slope m times x minus x1. Okay? And there you have x1, y1 lies on the graph. x1, y1. These are the point. You pick a line and that's on the graph. x1 and y1, and you're solving for y and the x value. You're writing the equation in terms of y and x, okay? And the slope is, m is the slope. So we have y minus 1 is equal to minus 2/3 x minus 1, okay? So where does this point intercept? What is the point we're dealing with here? It's 1 and 1, right? That's the point we're using. Y comma, 1 comma 1. Okay? This was fun.